Hello, I'm Mr. Franklin, and today we're going to go ahead and start looking at chemical reactions. The secret to chemical reactions and understanding them is you have to think of them like they're the recipe for what we're working with. So for example, if you're going to make a sandwich, let's say we're going to make a ham and cheese sandwich, so I know I'm going to need 2 slices of bread, I'm going to need some ham, I'm going to need some cheese, and then if you want to put lettuce, tomato, or any of that other stuff, you know that that's the recipe. Okay? If I want to make 2 sandwiches, how many slices of bread do I need? I need 4 slices of bread. So we have this recipe that we can put things together and come up with the final product that we're looking for. That's what these reactions do, is we take a chemical like aluminum plus copper chloride, kind of like we did in our lab, and when we put them together, it's going to produce or react to make something for us. And in this case, it makes aluminum chloride plus copper. Okay? So chemical reactions is simply that. It's a recipe. Okay? Now, based on what we've been doing and things we're going to be doing in the future, we're going to be able to tell if I give you 3 grams of this, I'm going to be able to just figure out how much of this I have. Okay? So before we can even get into that though, we need to refamiliarize ourselves, because most of this is stuff you should have seen already. But we're going to refamiliarize ourselves with the parts of a reaction, and then we're going to get into how do we write them, and then we're going to get into some types of reactions. So let's do that. So here's our reaction. Now, we have, on this side, we have reactants. Okay? Reactants is basically what we start with, and we put them together, and it's going to produce products. Okay, so whenever you see this arrow, you're going to think of the word produce, because that's how you would read it. Now, if you look at this, I've rewritten the same reaction, and I've put some other things here in parentheses. Okay, and I can show you what those. But this tells us what state of matter it is. So, for example, this says aluminum, which what state of matter was it in when we put it in used it in our lab? It was a sheet of aluminum, right? So it was a solid. Now, how do I know if that's that versus, say, aluminum hydroxide, or aluminum and sulfur? How do I know it's that versus a solid? Well, this should be lowercase, which if it's typed in the computer, it's easier to tell. That's why usually when I handwrite them, I leave those off, because it can get confusing. But there are some reactions where if all of a sudden the state of matter changes, it can be important to us. So these are our reactants. In between is we have these plus signs. The plus sign means we're going to put those things together. So if I put those together, it's going to produce something. Okay? So the arrow points to the products. We could also say produces. Okay? Now, most of the time, up until now, most of you have seen the arrow always going that way. Okay? But we're going to do reactions where we can do the reverse reaction. We can cause the reaction to reverse itself, and the arrow might actually point the other way. Okay? Sometimes you will have a double arrow where the reaction goes one way for a little bit, and then it immediately turns around and reverses. Like ammonia and ammonium, they do this. It goes from NH3 to NH4 back and forth. Okay? There's lots of reactions that do that. They go back and forth. And we can actually change how much it goes back and forth. Okay? And well, we'll get into that later, because that can be confusing if I throw that word out just yet. So, with that said though, if you do see these in parentheses and they're lowercase, that's important, they're lowercase, that means solid, cursive L means liquid, gas, and then AQ, don't freak out when you see it, it just means aqueous, and what does that really mean? It means you dissolved it in water first. So let's go back to this reaction. This is what we did in our lab. We took aluminum that was solid, plus copper chloride. It started out solid, but what did we do to it? We actually dissolved it in water, right? So we made it be aqueous, right? And then when we put the aluminum in, we had some stuff happen, That's what the arrow is talking about, okay? And it resulted in aluminum chloride and copper. So if you hadn't figured out by now, guess what the brown stuff was that showed up in your lab? It was copper. If you don't believe me, here is a picture of it. Here's a picture of it from after someone's lab, okay? So that's the basics of how you would read this is we have aluminum plus copper chloride, which are reactants, and they produce aluminum chloride plus copper, which are products. Okay? All right. So that's kind of the basics of this. So what you're going to do in the next video is we're going to look at different types of reactions, and we're also going to look at how to complete this.